Well, hello and welcome. I'm Richard Vannoy, and I'm here to talk about electronics training. If you're interested in the kind of training that at your local college would lead to an eventual degree in electronics engineering, then pay attention to this. I've got some good information for you and some good training for you. This training is the equivalent of a first semester course called DC Electronics. It's an 8-week course, and the first week covers these topics. First, we talk about how electrically all materials in the periodic table of elements fall into one of three categories. Either they're conductors, they're semiconductors, or they're insulators. We'll talk about those three differences and how they're used in electronics. We'll also begin our first look at schematics and schematic diagrams and circuit diagrams, and we'll start talking about and showing you the basic schematic symbols that you'll be using. For example, here's a symbol, that squiggly line shape that all the red arrows are pointing to. That's the schematic symbol for a resistor. And around that schematic are a bunch of images of resistors and what they look like. Resistors are one of the most common components in electronic circuits, and so we'll look at those and how they work and what they do. For week 2, we'll look at a gent called Mr. Ohm, who way back when worked out a lot of the relationships between voltage, resistance, and current. He did some of the very first scientific discovery of how electronics works. And as you see here, you see V, I, and R. They're the letter symbols for voltage, resistance, and current. So we'll look at how voltage, resistance, and current work and how they tie in with each other and how they relate to each other. We'll talk about voltage, or EMF, which is short for electromotive force. We'll explain what voltage is and how it's used. And we'll learn that in a simple electronic circuit or electrical circuit, what happens is electrons flow through that circuit to perform work and do the job that we want it to do. We'll talk about that electron flow and how it works. One of the characteristics in electricity and electronics is resistance. And we'll talk about what resistance is, why do certain materials resist the flow of electricity, and how do we use that to our advantage to make things work the way we want them to. And we'll get our first look at what I call the Ohm's Law wheel. This wheel shows all of the relationships between volts and ohms and amps and watts, all of the things that we use to measure electricity and electronics in electronic circuits. So we'll get a first look at this wheel and talk about what we're going to use it for. Week 3. Well, we've talked about Ohm and Ohm's Law. We'll get into Ohm's Law triangle, which you see here, several versions of it. We'll talk about how that triangle is used to solve for the quantities in an electrical or an electronic circuit. We'll go deeper into the Ohm's Law wheel, and we'll have you practice the formulas that you see on the two wheels here. We'll discuss how some of the characteristics in electricity and electronics are directly proportional, some are inversely proportional. So we'll talk about what's the difference between this direct proportion, inverse proportion, and how does that work in relation to Ohm's Law. We'll look at scientific notation. Down on the bottom right are several ways that we show large numbers or very small numbers with lots of decimal points to the left or to the right. And this scientific notation is the way that we actually present large numbers to make it easier and to make it shorter. It's a shorter notation. We'll explain how that works and how you convert from one to the other. We'll do exercises like this one. This one asks that you convert 6,218 into scientific notation. You'll learn exactly how to do that. Week 4. In this week, we'll talk about metric units and conversions. Notice the prefixes on the left, tera, giga, mega, and others. These prefixes are used throughout the electronics world to describe very large and very small quantities of volts, ohms, and amps. We'll talk about those and how to use them. We'll get into the resistor color codes. We'll look at the colored bands around resistors, what the color code is, and how I can convert that color code from just colored bands down to the exact value and tolerance of an individual resistor. We'll start looking at power, very simple power. What is power? How do we measure it? What formulas do we use? In order to handle power, how do we work with power? We'll start looking at digital and analog electronic test equipment. You see several items here. Some of them are called multimeters or digital multimeters. Their whole job is to take readings inside electrical and electronic circuits, and we'll show you what they are, what they look like, and we'll start using them and showing you how to use them in circuits. Week 5. Well, it turns out that when we look at resistors, and this quarter is mostly about resistors, we'll get into other components later, but it turns out there are only 4 ways we can hook up resistors, and they're shown on this screen. And we can hook them up in series, in parallel, in series parallel, and then there's a more complicated way we can hook it up. And we need to know that, and we need to know how to solve circuits that are hooked up in these ways. So we'll start looking at these 4 resistor configurations. And then as we lead off from here, we'll start working with series, and then later we'll work with parallel, and later still with series parallel circuits. And all 3 of those will be covered in this semester. For example, here's a practice sheet where we look at some series resistors, and we want to know the total resistance of the circuit. So we talk about the rules and how we add up the totals, and how we discover what the resistance of a circuit is. We'll get into one of the 2 laws that a guy named Kerkoff came up with. He has a law called Kerkoff's voltage law, and it has to do with the algebraic sum of voltages in a circuit. We'll explain how that works, what his law is, and how we can apply that law to solving a specific circuit. We'll talk about current in a series circuit. What are the characteristics of current in a series circuit? And we'll look at that, and we'll learn how to solve for the total current in a circuit. Using the Ohm's law wheel that you've seen before, we'll take a few sample circuits, like the example circuit on the left of your screen. We'll solve those circuits, and we'll look at what's the voltage, what's the amperage, what's the current, what's the resistance. So we'll look at the things that we have for the circuit. We'll learn how to use the Ohm's law wheel to determine things like voltage drop, current in the circuit, individual current in each component. We'll take a series circuit like this one, and we'll take it apart piece by piece, and you'll be the one to determine what is the voltage, what is the current, and what is the resistance of every single component in this circuit. Week 6. In week 6, we start talking about something called the voltage divider formula. This is a very important formula that helps us determine what's the voltage and what's the current in series circuits. So we're getting to the nitty-gritty of what are all of the things we can do, what are the tools that we have to solve series circuits. And the voltage divider formula is very important in helping us do that. And we'll look at some simple voltage divider circuits. Here's one of the examples. It's a light sensor. It's called a cadmium sulfide because that's the name of the chemical used in it. And this chemical is sensitive to light. And what that does, it helps us determine the amount of light that's shining on something. So we'll talk about how these are voltage dividers and how they work and how you see them in everyday use. Well, we got to look at Kerkoff's voltage law a little while back. We're going to dig into that a little bit deeper, and we're going to have a practice problem or 2 that'll show us how to solve and how to use Kerkoff's voltage law to help us or to solve the problems in a circuit. Week 7. In this next to last week of the semester, we're going to look at parallel resistance circuits. And you can see some examples here on your screen. We're going to describe what's the characteristics of a parallel circuit. What are they like? How do you know the difference between a series and a parallel circuit? And we spent time in the last few weeks solving series circuits. Now we're going to begin solving parallel circuits. We'll look at a thing called conductance and a thing called resistance in these parallel circuits. We'll talk about a few of the formulas used that helps us understand how these circuits work. We'll learn a formula called the product over the sum, which is shown in the top line of the red formula on the screen. We'll use that product over the sum formula to determine the resistance, the specific resistance of individual resistors, or total resistance or equivalent resistance in a circuit. So the product over the sum is going to help us to solve a circuit and find out what's going on in the circuit. We'll also learn another tool called the current divider, and the current divider is a formula that helps us determine how the current flows in a circuit when it has a possibility of going one way or the other. And to kind of wrap up, because we now know the rules for series and the rules for parallel, to help us make sure we understand the differences, this particular slide is part of a short exercise in which we take a series circuit and we take a parallel circuit. The series circuit's on the top, parallel on the bottom. And we solve each of those circuits, and the solution for those is over to the right. And then we make comparisons. We talk about what are the differences? What's the differences between what happens in a series circuit and a parallel circuit? And that becomes very important in order to analyze these circuits and to solve them and figure out what's going on. We talk about power in a parallel circuit. How do we compute power? What is power? How do we figure out the total power in a circuit? How do we figure out the power of individual components? So we'll discuss that. Here are the parallel equations. These are the equations that you'll need to learn and need to know and have in your toolbox so that you can solve parallel circuits. And it might look a little complicated here, but we'll break each one of these apart one by one, explain what it means, how it works, and how you can apply that. So that by the end of this week, you'll be able to use any or all of these equations to solve a parallel circuit. Last week coming up, week 8. So the first thing we need to do as circuits get more complicated is we need to identify series parallel circuits. We've worked with series for a week or two. We worked for parallel for a week. So we've solved and worked with each of those individual circuits. Now's the time to put them together. The circuit on this page has both series and parallel components to it. So we need to understand the rules. We need to understand the rules of series, which we've already learned. We need to understand the rules of parallel, which we've already learned. And we're going to go a little farther. Now we're going to find out when we have a series parallel circuit, how does it work? How do the rules work together? And how do we keep them apart? And what are the steps that we need to do to solve a series parallel circuit? We'll learn something called parallel notation. We'll learn how to solve a circuit. The circuit on your screen, we'll learn everything we can about it. We'll learn the voltages, the currents, and just what's going on in that circuit and how to apply the rules that we've learned. Once we can solve for voltage and current and resistance, we'll solve for power. We can figure out the power in each of the components in a circuit and, of course, the total power. So we'll learn about how that works. And we'll learn how to do some checks. This is one of the circuits that we work through in great detail in this week. And we really do a lot to determine what's going on in this circuit voltage and current wise. When we're done, we'll figure out ways or show you ways so that you'll have tools to do some real basic checks on your circuit to make sure that your mathematical calculations are correct and you didn't make a mistake somewhere along the line. That's the 8 weeks, and the key things that you're going to learn are the 8 things on this slide and the next one. 1, identify basic schematic symbols. 2, you will learn how to identify the relationship between volts, ohms, and amps by using Ohm's law and the Ohm's law wheel. The third item, you'll use the Ohm's law wheel to solve resistive circuits. And 4, you'll learn how to use resistor color codes to identify the value of resistors. And 5, you'll be able to totally solve series circuits for voltage and current. Number 6, you'll learn exactly how to use the voltage divider formula to determine the current and voltage in any series circuit. And 7, you'll use a formula called the product over the sum and another formula called the current divider formula, and you'll learn how to use both of them to solve parallel resistive circuits. And lastly, you'll use all of the skills above in all of the weeks of training to solve a series parallel resistive circuit. And that'll be it. You will then become a wizard of series and parallel resistive circuits. So that's a summary of the 8 weeks training, the full semester of training. Thank you for listening. And as a reward for going through this entire video, I'd like to offer you the first course in this 8-week series for free. You'll see up top the course links for each of the 8 weeks of the 8 weeks course. And down at the bottom, you see a coupon code, ELEC, #1 free. If you go to that first link for week 1 and you insert that coupon code to sign up for the course will be given to you for free. So please go try it out, see what you think, let me know what you think, and thanks again for viewing this video.